Hello, my name is Grant Fritchey. I work for Redgate Software. I want to talk to you about bad advice. So there's a checklist of query performance hints that have been making the rounds. And yeah, they're not very good. Now here's the thing. Creating a checklist of hints that, do these 4 things and your queries will run fast just never works. There are certain things you can do, there are certain things you can look for, but there's this list it's problematic. It's seriously problematic. I've already posted a blog post on it, and I'll send a link over to that, but I want to follow up on this. I'm trying hard to get this list, to make it disappear. If there was a way to get into Google and Bingle and whatever the other search engines are and make it all disappear, I would. There's not. I tried. Kidding. The only way we're going to get rid of this is to rebut it on a regular basis. So I'm going through the list right now. We're going to take it down one by one. So, first tip. Index the predicates in join, where, order, and group by clauses. Okay, true. What about having? And what kind of indexes? Do we do column store? What order do we put them in? What are the keys? What are the include operations? Basically, all this tip says is indexes are good. I agree. Indexes are good. Yeah, we need to say more about it, don't we? There's more to it than just simply saying indexes are good. That's, picking and choosing where you apply an index is a lot of work. There's a whole bunch involved. And just saying that, having an index is a good thing is not adequate, because you can also over-index. So, all right, so next tip. Do not use SP underscore naming convention. SP underscore whatever my proc name is. Yeah, this is true. This one's actually true. It's just, it's low-hanging fruit. It's a little tiny thing. Yeah, can we do it, and can we save a millisecond or two? Yes, absolutely. It'll save 2, 3, 5 milliseconds, maybe 2, 3, 5, maybe 1, maybe half of 1, depending on the system, all kinds of other things. But it doesn't really cause any major performance bottlenecks, unlike other things you can do to your system. So this is not that big a deal. The next tip says, explore the tables used in the select statement so that filters can be applied in the where clause. When there are queries with subselects, try to apply filters in the inner statement of the subselects. Yeah, filtering is good. A where clause is good. Filtering anywhere is good. Reduction of rows so that we're not processing 1,000,000 rows when we need to return 3. Yes, filtering is good. But that hint is really vague. It's off. It doesn't provide real guidance, because it doesn't tell us what to do. Put indexes on things in where clauses. Again, it goes back to indexes are good, filtering is good, and it doesn't narrow things down. Only the columns which are selected will be read while using a column-oriented database management system. Does that mean only move the data you need to move and only move it when you need to move it? If so, I agree with that sentiment. The idea that you only should move the columns that you need to move, it makes sense to me. Only move the data, filtered by your where clause makes sense to me. This doesn't make any sense to me, this tip. I just don't know where they're going with it. It's not, I don't know, what's the right word? It's not real. It's not a real tip. It doesn't make any sense. It's not telling us what to do about our queries other than, only move the data you need to move. And also, why column-oriented? I mean, are we talking column store? It's not connecting. So, I mean, it's a lack of clarity. I would not say this one's bad. It just doesn't make any sense. Remove the joins from the unnecessary tables, which will help reduce the database processing time. Okay, so the concept here is that joins are bad, except that we're in a relational database engine, and therefore joins are sort of a necessary part of how it works. So minimize the joins that you use, I guess, is what it's saying. I agree with only use the joins that are necessary, but this makes, again, no sense. All right, next one. In the select statement, avoid writing star. Okay, so select star is, I don't want to say bad, but again, it goes back to move the data you need to move when you need to move it. If you need to move everything, select star is actually an easy way to do it. Most of the time we don't need to do everything, so it doesn't make any sense there. Okay, so if possible, avoid using incar and invarchar, or inchar and invarchar, I'm not going to get into that debate, as both the data types take double memory as that of car and varchar, or char and varchar. So here's the deal. Do you need to store international language data sets in a single database so that you're storing, if you're speaking and writing Farsi, and you also need to speak and write, some form of Chinese or Japanese or something else, do you also have to have, do you need to store this? You know what you're going to use? Incar and invarchar. So using incar and invarchar when you don't need it, I get it. That doesn't make sense. It does double your storage. But if you need it, you use it. So this is not a performance tuning tip other than use the correct data types, use the correct data sizes. Other than that, this isn't really performance tuning. Try to avoid using null in a fixed length field. Again, there's so many caveats around this that this hint in and of itself doesn't make any sense. If you've got a definition such that the definition of your data is that you've got a null field and it's a fixed length field, it's an int, make it null. This has to do with like the really granular low level storage, and it doesn't seriously impact performance that much. It's nothing that we need to panic on. Avoid the having clause, as this clause is required only if the user needs to filter the result of an aggregation. Yes, if you're filtering an aggregation, you're going to use the having clause. If you're not filtering an aggregation, you don't use the having clause. If you're not defining a CTE, you don't need to define a CTE. If you're not, this makes no sense. This is not a performance tip. If you're not aggregating data, you won't be using the having clause. Period. You'll be using the where clause. I got nothing. This one, again, it's not that these tips are all bad. Some of them are bad. We'll get to the bad ones in a bit. It's not that the tips are bad. It's that the tips are extremely unclear. These aren't going to help you increase performance. This isn't going to improve your performance. Nothing to it. Okay. Create clustered and non-clustered indexes and keep clustered index small. Sometimes it is also used in a non-clustered index. Okay, so first up, indexes are good. Yes, we already know this. So yeah, create clustered and non-clustered indexes. Which ones, when, where, how, why. See, that these tips are not tips. It's not, use indexes. Yay. Okay, also, sometimes clustered indexes are used in non-clustered indexes. No. Always clustered indexes are used in non-clustered indexes. When you have a non-clustered index on a clustered index table, to find the row for the non-clustered index, the point lookup value is the clustered key, because that's where the data is stored. If it was a heap, the RID, the row ID lookup, is what would be used in the non-clustered index. But that is an always thing. That is not a sometimes. No. Always. A non-clustered index has to have a way to get to the data itself. That is either the row ID in a heap or the clustered key for a non-clustered index. Always. It is a smart approach to create indexes on columns which have integer values instead of characters, as integer values take less space than character values. Okay, so I'm filtering on last name. So I'll put my index on another column someplace, age, because that will help the filters on last name somehow. No, it won't. This one makes no sense. Yes, does an integer run on, does a unique integer, say, run faster than a unique string if that unique string is bigger than the unique integer? Absolutely, right? Narrower indexes are better. Numbers are easier to manage, right? They sort better, and again, that works well for computers and computing and all that fun stuff. But again, this is problematic suggestion here because it doesn't work. This is not a performance tuning measure, because if you need to filter on a string, you filter on the string. If you need to put an index in place for that filter, you put that in place for that filter on the column you're filtering on, not on some other column. Wow. Okay, that one's dangerous and silly. Let's see. Use the where clause to limit the size of the resultant tables. Yes, where clauses are good. Okay. Select the appropriate data type. Yes. Yes, 2 thumbs way up. Select the appropriate data type, even if it's a varchar, in varchar, even if it's Unicode. If you need Unicode, use Unicode. Dates are dates. Strings are strings. Don't put dates in strings. Don't try to put strings in dates. It won't work. Use the correct data type. That's just common sense, although lots of people don't do it. But that one's, that one's a correct, 100% correct. All right. Now it gets fun. To improve query performance in SQL Server, use Tablock X while inserting into the table, and use Tablock while merging. Okay, so while we're inserting, we're going to put an exclusive lock on the table, because that will improve performance for that insert and that insert only. Everything else will have to wait, because we are taking out an exclusive table lock. Tablock X, T-A-B-L-O-C-K-X, Tablock X, exclusive table lock. Lock the whole 10 million row table so I can put 1 row in. Meanwhile, the other rows that needed to be updated, deleted, whatever, they're waiting. They get nothing. They get no attention, no love. By the way, because it's an exclusive, you can't take out new shared locks, so new reads will also be waiting. This is a very bad performance tuning suggestion. It will increase the performance for one query at a time, but it's not going to increase the performance for your system. It's dangerous. This is very dangerous suggestion. Don't do this. You may, through testing, determine that, yes, in fact, situationally, and I mean very situationally, small, tiny, carefully defined, very well tested situations, you need to put a Tablock X on. Yes, that can happen. We have query hints because they are useful, but we need to be very cautious about using them. And we do not say every insert query gets a Tablock X. That is insane. Every merge query gets a Tablock. No, no, no. We tune, we tweak, we test to validate that what we're doing is going to work well for the index in question. For the hint, if we want to put hints in, we do not blanket approach these things. It does not work that way. Try to use set no count on and try catch, which will help avoid the deadlock condition. Also, try to use with no lock while querying the data from any given table to improve query performance in SQL Server. Okay, so what we've actually got here are 3 tips. They're all bad, but there are 3 tips, not 1. So, set no count on. Yes, I agree with this one. You absolutely should set no count on. It prevents a round trip, which will reduce overhead, which will reduce network use, which will improve a tiny bit, which will improve performance. Cool. So set no count on. Good. Use try catch because it avoids deadlocks. No, no, no. Wrong, wrong, wrong. Try catch will allow you to try an insert, update, delete, and see if it has a deadlock and allow you to catch that error and then retry the insert, update, delete. Yes, it can help you deal with deadlocks. It will not avoid the deadlock situation at all. This is all about error trapping in your code to ensure that you are ensuring that you don't return the message, you've been chosen as a deadlock victim, because nobody likes that message, right? I'm not a victim. But the whole key here is this isn't a performance enhancement. In fact, this is going to hurt performance a little bit because you're going to try to do that insert, get a deadlock, have to undo that deadlock, undo that transaction, try it again. So that's going to cause overhead. That's additional load on the system. That's not reducing load, right? Query performance tuning is about all making things faster so they have less load. This isn't going to help there. So, this is a protection mechanism, try catch, but it is not a performance enhancer. It's not going to help. It's not going to help. This is a bad tip. All right. Next tip, no lock. Set no lock on because it makes things run fast. It's true. Things will run faster with no lock. Cool. You don't need to listen anymore, right? No one else can hear me now because I'm not going to say anything else, except I am. I'm going to say one more thing. So no lock. Everyone thinks what no lock means is that I'm the locking mechanism is protecting me from reading dog while it's getting updated to cat. Well, and I don't care if it's dog or cat. Either one works fine for me. I'm cool. Yes. Except when you take away locking, you say no lock, and it's scanning. So it's reading one row, one row, one row, one row. Now it gets to about here. The page down here gets an insert. Because assuming we're not doing table locks, we're actually able to let more than one thing happen on our system. An insert occurs. It splits the page. Now, this bit gets moved up here or over here or someplace else. And meanwhile, we keep reading rows. And notice we're going to miss this bit because it's gone. So, no lock can cause us to miss rows. We can have missing rows in the result set. It's not simply dog-cat thing. No, no, no. Missing rows. Better still. We're reading rows. You get down to here. Insert occurs. Or say we get down to here. We've read these rows. Insert occurs. Page split happens. This page gets moved down to here. Row, 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 row. Oh my gosh, we've read these rows before. Yes. No lock can cause you to miss rows entirely or read rows more than once. That's very problematic for systems. You really want your banking system to occasionally miss the fact that you made a deposit? You want the banking system, sure, I want them to miss the fact that I made a withdrawal. That's in my favor. But, oh my gosh, this is not what this system's all about. If you need to get consistent and clear data out of your system, you must not do this. And if you have to do this, if someone on high says, we don't care, we know that it's just going to cause nothing but data problems, but by gosh, performance is king, and who cares if the data is right as long as it comes back. By the way, you can make the data come back even faster if you truncate it. But if there's no data, queries run quick. Anyway, if you have to do no lock, don't. Don't do no lock because it requires you going into every bit of your code and updating all your code to get the no locks in. Don't do that. Change the connection string to read uncommitted. That's exactly the same thing as no lock. It's exactly the same thing as no lock. But then when you finally realize that you're killing your system, that you're losing data or you're duplicating data or both in the same query set, you go to one place to turn it off. You change the connection string again. Yay, we win. Rather than, okay, cool, we just have to modify, 18 million lines of code. It's no big deal. Please, please, please don't use no lock. Except in very, again, rare circumstances where you very carefully measure and very carefully identify that here and only here we need to use the no lock hint. The no lock hint exists for a reason. It's okay to use it, but these must be exceptional uses. When the exception becomes the rule, when you say you must put it everywhere, that is no longer an exception. It's like, well, I'm an exceptional person, therefore I get to use no lock anywhere. It doesn't work like that. I mean, in fact, using no lock everywhere does make you an exceptional person, but it doesn't make you a smart one. So please, please, please don't do that. This is a dangerous tip. If table variable is used in place of temp table, it makes a great increase in performance. No. Sorry. No, it doesn't work like that. Here's the big deal. Temp tables versus table variables. Both are written to memory. Both are written to disk. Both temp tables and table variables get written to disk. Both get written to disk. This whole table variables only get written to memory is crap. Both get written to disk where? Well, that temp gives it away, tempdb. So they're both dumped in the tempdb. Both, no matter what. One of them has statistics, one does not. Temp tables have statistics. Temp variables do not. Temp table statistics can hurt or help performance. They can hurt performance if you need to filter, join, or use the temporary table in some fashion that requires filtering and joining and that type of thing. Statistics. If statistics are needed, it helps increase performance, but it comes with a cost. It leads to some statement level recompiles, and statement level recompiles can be costly depending on the statement, depending on the system. So the balancing act here is not table variables good, temp tables bad. The balancing act here is recompiles hurting me, therefore table variables, versus need statistics, therefore table variables bad. If you need statistics, you're going to want to go with temp tables. If you are suffering from recompiles, you may want to test with table variables. But you may sit situations where you're suffering from recompiles, but the statistics still help. So you're going to have to test this stuff. This, again, is a bad hint. Next, if union all is used in place of union, this improves speed and therefore improves SQL Server performance. Sure, as long as you don't care about the data set that's coming back. If the results don't matter, just use union all instead of union. Union is an aggregation query that's going to get you a distinct result set. Union all is saying, hey, I don't need the distinct result set, just return, if I'm unioning two tables, just return everything from both. But that's changing the results. So again, we're back to if you can change the results, truncate the tables. It will run faster. Man. Okay, next one. In case of complex and frequently used queries, use stored procedures for rapid data retrieval. No. I'm a fan of stored procedures. I love store procs. Store procs are my friends. Store procs are your buddy and your friend too. But store procedures, only magic is the parameterization. Now the parameterization makes it so you can reuse that code from cache. It will compile the plan necessary for the query once, and then every time that query gets called again, because it's got a parameter, and it can use those parameter values instead of hard-coded values and or variables, it can go in there and say, hey, I recognize this thing, let me reuse it, let me reuse it, let me reuse it. That's the magic. You can parameterize queries through ORM tools such as Entity Framework, and they will work almost exactly the same way as stored procedures in that regard. So therefore, except for a little bit of masking that you can do inside of a stored procedure, settings and security that you can do inside of stored procedure, there's not actually a performance reason to go for stored procedures over any other kind of code except the parameterization values, and you can parameterize other ways. So this magic that stored procedures are going to provide you with unknown, unheard of performance enhancements because you've gone to stored procedures, no, it doesn't work like that. Next one, multi-statement table-valued functions are expensive compared to inline table-valued functions, hence avoid using multi-statement table-valued functions. Unless you're on SQL Server 2019 and you've got a scalar multi-statement table-valued function, when those two things are true, evidently, I've still not seen all the tests that I want to see, but they are way better, way better in 2019. But, hey, look at the date. It's not 2019. Look at your version of SQL Server. I'll bet it's not 2019 either. This is one tip I completely 100% get behind, but I would go further. These things are evil and should be avoided. Multi-statement table-valued user-defined functions should absolutely be avoided unless you're on 2019, and even then, they still don't perform as well as other options that you can do in the code. So while there is less pain, we have not eliminated the pain with these things if you're on 2019. Regardless, here's the deal. This was a bad set of tips, and I don't know where they came from. They're old. They're a good 10 years old, this tip. It's like a game of telephone. They keep getting copied and modified, and somebody copies them and rearranges a couple of words because plagiarizing is bad, but if I copy everything and change 3 words, I'm no longer plagiarizing. So these things have been traveling around a lot, and like a game of telephone, they don't quite say the same things they used to say, but enough of what they say is still very problematic that we need to be out there rebutting this stuff. Please, please, please test your code. Do not assume that any of these tips or any of the things that I tell you are going to work well. Validate that the suggestions that I make, suggestions that anyone makes, are going to work well for you. And anyone who's giving you hardcore blanket statements, replace a temp table with a table variable, everything will work perfectly, put Tablock X on all your insert queries, don't listen to that person anymore. There's serious problems if they're not able to caveat out their suggestions. So even my suggestions, I've got caveats, lots and lots of caveats. I can keep going on the caveats. I try not to because I want to be clear, and the caveats kind of muddy things up. But the key is that you need to understand the caveats, because you need to know when things should be used and when things should not be used and how things ought to be used. Without the full knowledge, if you're just going off this set of tips, here's 8, 10 things, whatever it is, 12, I don't know, that guaranteed make performance faster, they probably don't. And if you just use them blindly, you're going to be hurting your systems. So I'm begging you, please, 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 don't do that. That's it. Please subscribe. My name is Grant Fritchey. I work for Redgate Software.